suppose you had the vector 4, 3, and you want to take the magnitude of it. You can do this with Pythagoras using 4 squared plus 3 squared, all square rooted, and that gives you 5. And this could be shown graphically. So you've got your x and y axis. X axis is 4, so about here, and the y axis is 3. So it's going to be about this point. It's going to come from the origin. And so that's 4 and 3. And this is forms a right angle triangle, so you can use Pythagoras. If you want to calculate theta, the angle from the x-axis, use simple trigonometry, so SOHCAHTOA. Once you find that this length is 5, you can use any of them, but it's best to use tan because then you use the numbers you're given rather than the one you calculated, there's less chance of error. So tan theta is opposite over adjacent. So opposite is this one, which has a length of 3, and adjacent is this one, which has a length of 4. And if you inverse tan this, you have theta equals, which equals 36.9 degrees. The exact same logic can be applied to three-dimensional vectors. So if you have 4, 3, 2 in the x, y, z coordinates, directions, you're going to have 4 squared plus 3 squared plus 2 squared, all square rooted, which equals the square root of 29. A unit vector is defined as the vector itself, so say v, the underline shows it's a vector, divided by the magnitude of v, which is shown by these lines either side, and that is written with v for vector with a hat on top. So if you take an example of 4, 3 again, we know the magnitude is 5, so you have this, and that's going to give v hat equals 4, 3 multiplied by 1 over 5, and if you want you can multiply it out, so you're going to have 4/5 and then 3/5. There are 3 certain unit vectors that are useful to know about, and they are I hat, j hat, and k hat, and they are defined as I hat is a one direction in the I direction, which corresponds to x, so it's 1, 0, 0. J hat is in the y direction, so it's 0, 1, 0. And k is in the z direction, so it's 0, 0, 1. So if we go back to here, you would have v is equal to 4i plus 3j over 5. If you want to write a line in vector form, it's going to be in the form of r equals a plus lambda d, where a is a point the line goes through, and d is the direction it's going in, and lambda is just a scaling factor to specify the length of the line. So if you take a line going in the direction 2i plus j, and it goes through the point 4, 3, you're going to have r is equal to 4i plus 3j, because that's the point it goes through. And you need the I and j notation here, plus lambda, the scaling factor, times d, which is 2i plus j, and that should be all multiplied by lambda. If you want to find that angle between two vectors, you need the dot product, also known as the scalar product, and it is a dot b is equal to the magnitude of a times the magnitude of b times cos theta, where a and b are the two vectors and theta is the angle between them. So if we take the example a equals 1, 2, and b equals 3, 4. So first you need to find the magnitudes of each one. So magnitude of A is square root of 1 squared plus 2 squared, which is root 5. And magnitude of B is 3 squared plus 4 squared, all square rooted, which equals 5. And then if you rearrange this formula to theta equals arc cos of A dot B divided by magnitude of A times magnitude of B, and then sub in these numbers, you have arc cos of A dot B. So to calculate the dot product, you multiply the x values and then the y values and then the z if there are any. So 1 times 3 is just 3, plus 2 times 4 is 8, and then you divide that by root 5 times 5, which is equal to arc cos of 3 plus 8 is 11, and then 5 root 5 is 5 to the power of 3 over 2. And if you put that in the calculator, you get theta is equal to 10.3 degrees. If two vectors are perpendicular to each other, you can see that their dot product between them is equal to 0. To check whether two vectors are parallel to each other, one will be a scaled version of the other. So if you want to know if the vector 3, 1 and 18, 6 are parallel to each other, you can see that 3 times 6 is 18 and 1 times 6 is 6. Therefore 18, 6 is equal to 6 times 3, 1. So these two vectors are parallel to each other.